We're live.
We're live. Hello, everyone. This is Amit here, and welcome to Office Hour Week 3. And we also have, as usual, Alessandro. Hey, Alessandro.
Hello.
Hey, so it's Christmas time, or close to Christmas time, I guess. It's the holidays, and I really hope some people are watching this or will watch this. It'd be nice that if people can take time out of Christmas to watch data science, maybe. Well, we have. So I think we have a set of questions that we want to kind of kickstart, and I don't know. I think I wanted to kind of start from where we think most of the people are at this moment. I think they are at kind of section 2 or the EDA part, exploring and visualizing data with R, and I kind of talk a little bit about visualization and kind of touch upon a couple of themes there, both on how to visualize and what to do when the data becomes too much. And then also go out to tools a little bit and say, what to do with these tools. Is R good enough? Or, when do you want to open the horizon and try more tools, and when do less tools? And then we'll talk a little bit about finding data, maybe scraping data or getting data in acquisition, and then a couple of more heavier questions and getting into techniques, and maybe talk about clustering today and say, what to do with clustering. So let's kickstart. I mean, data is getting bigger, medium to big size data. So I want to start a little bit with there, and then come to how to visualize it. But what do you do, Alexander, when the data becomes quite big and you start to hit some of the limits within R, and you can't really take everything and aggregate, take each element of the data from an SQL dump or even something bigger, and you can't just put everything to R unless you maybe run a R on an Amazon machine with maybe 64 gigs of RAM or 128 or maybe even bigger. I don't know. So what do you do? What can you do to actually still manage that data in R? Get that data in, and then do you need to do something different to visualize it? Like, do you need to do something different or think about differently how to visualize it? How do you bell that cat?
So just to define our terms, when we talk about small, medium, and large data, what we typically mean is small data is data that can fit in memory on your computer. Medium data is data that maybe spills over onto your hard disk, and depending on how seriously we want to define this, we might define this at the point where it's no longer tractable to keep it all in R, or maybe it is in R, but it's having to swap out to disk a lot. So at that point, it starts getting simple. And then big data is where it can't even fit on your computer anymore.
Okay, that's useful. Yeah.
So once we get out of small data, then we start to feel the pain of how R expects everything to live in memory. It's not very good at swapping data in and out of memory very efficiently. So we need to give it a little help. And so one of the best ways to do this is to kind of figure out how you want to slice your data, how you want to, on what dimensions you want to aggregate it, and actually perform those aggregations using your database. So whether your database is some huge parallel processing database like Redshift in the cloud, or whether it's it could be a SQLite database or a Mongo database that's hosted on your own computer or whatever. You often want to do all the aggregations in the database because the database is going to be able to deal with the large volumes of data much more efficiently than R will.
Right.
The trick to that is that once you've started to aggregate the data, a lot of the functions in R kind of expect to be looking at not aggregates, but looking at the raw data. So something like in ggplot, where you plot two variables against each other, it's expecting to see each row being an individual instance.
Correct.
So it will calculate the density on its own.
Mm-hmm.
But when you've pre-aggregated the data, you've already computed the density, and computing the density on a density, you end up with really weird results.
Right.
Hi, Julian. We have somebody joining our call. So if you want to, let's see, if you want to ask a question, I think I'm not sure exactly how we can I guess just maybe say something in the chat room, and then we can unmute you.
So that sounds good. Yeah, I think Monique has a control.
So raising your hand. All right, we got it. All right, cool. So where was I? So you can't.
Once you've aggregated the data, now you have aggregated data points as opposed to singular data points, which is what R typically or ggplot typically looks at. And how do you kind of now go from there?
So at this point, you need to kind of you might do things a little bit differently than you normally would. So for example, if you were to plot a histogram in this way. Well, if you call the histogram function in R, it's going to look at your whole data frame and count up the number of values and do calculate the density and plot it for you. If you calculate the density in your database, you're going to get those counts back, and what you actually want to plot is basically a bar chart.
Correct.
It's going to be effective histogram, but you're because the processing was done in SQL or whatever your database is, R is going to treat it like a bar plot. If you were to try to right, I think I said box plot and then bar plot. If you were to try to calculate a histogram on that, what you'd end up doing is calculating the densities of densities, which would give you something that's very bizarre and not at all what you were looking for.
Yeah. So how do you decide which of these which of these kind of columns do you aggregate on? Which of the variables do you aggregate on? Is it just trial and error, or you need to think about the question and then say which one would kind of compress the data enough to fit into R? I mean, there could be many dimensions to think about it, right? Compression is one, maybe thinking about what is the kind of analysis you want to do is maybe the other one, and then maybe which kind of visualizations also may play into it.
Yeah, and the cardinality matters also. So, for example, if you're looking at weblogs, it might seem to make sense to do something like aggregate on the user level,
right?
But that's still not going to fit into R. You're still going to have a problem there, unless you have a very small website.
Personal website, yes.
So hopefully, when you aggregate on the user level, it will not do that.
Right.
And this is for weblog data, of course. So you want to make sure that you're aggregating on a dimension that where you can reduce the amount of data significantly. At the same time, you might want to aggregate on more dimensions than you would necessarily look at any given time. So, for example, you might have 10 dimensions that you're interested in, and you might want to aggregate on all 10 different dimensions. And what that's going to do is it's going to create a data frame that basically has every possible permutation of those 10 dimensions. Now, you'd want to make sure that you'd only want to do that if those 10 dimensions are fairly small, like each one has only 5 possibilities or something like that.
Right.
Because then you're basically going to, when you do the combination of that, if you have if one has 5 possibilities and there's 10 of them, that's 5 to the 10th power rows.
Yeah, the rows you would have.
Still reasonable. I mean, but it's going to be you're going to be getting pretty high. And oftentimes dates are going to be going into that as well. So that's often a dimension that you're going to want. And then you might do an aggregation within R of combining over different rows.
Right.
So, for example, you might have both date and treatment and, say, platform type. So if the person is coming from a desktop browser or a mobile web or something like that. And you can't, maybe it's hard to plot all of these different dimensions all at once. So maybe to begin with, you're not going to care about the platform type. You just want to compare. You just want to look at date and the treatment. So you basically maybe you want to plot out 2 time series of different colors, with treatment A, one with treatment B, and collapse over platform, because you're not going to worry about that for this particular plot. So that's when you would use something like dplyr to collapse over, to do a summary and basically do a stop on the different, on across platform, and separate out the dimensions that you care about. And that, if it's small enough to fit in memory, you can play with that, till the cows come home. I mean, you can just keep rotating, swapping in and out dimensions, and seeing, all the different possible combinations. And yeah, so I find that to be a pretty effective approach.
And I guess a little bit of domain knowledge obviously plays a key part to say which variables I want to say. Which variables do I want to kind of keep on, and you may have to go back to your database and kind of play around with it a couple of times before you start to get this right intuitively, right? And start to see which ones, where should I aggregate, and how, then what should I. So what amount of data wrangling should I do in the database itself, or data aggregation, and how much of that then comes in, and then we will kind of do the rest of the stuff in dplyr, right? Or some R tool to kind of combine. So I think that's interesting, and I think it comes a little bit with experience and a little bit with some of the tricks that you kind of talked about. So that's great. I think before we go on to another visualization question, I think Julian has a question on Viz, and
so
hey Julian, do you want to kind of jump in and can we have his mic on, Monique, and then?
Okay, so I just so we'll see if this works. Julian, I just unmuted you and gave you visual. Let's see. So maybe you can grab the screen and share something. I'm not sure if this is going to work.
Yeah. Can you guys hear me?
We can hear you.
Yes,
yep.
we can.
Okay.
Yeah,
Cool.
okay.
Let's see. So I guess I'm going to do a screen share. Is that right?
Yes.
Okay.
Yeah.
Let me
the screen share on the left.
move some windows around here.
Why didn't you talk about it as you try and kind of get the screen share on?
So I have a histogram, and it's a stacked histogram, and I have probably let's see, about 19 variables that I'm trying to I guess find a better way to share this data. Can you guys see my screen?
Now we can. Yeah. No.
Okay.
All right.
Cool.
I see what you mean. So these are the 19 stacked colors in the lower right-hand corner.
Yeah. So I'm basically wondering if maybe there's a completely different plot that might represent this data better, or if there's maybe a different color palette that might make this more interpretable.
Right. So, and talk to us about so each of them is an year, right? So you basically have 19 bars or 20 bars?
So yeah, so the x-axis is years, and the colors are actually countries.
Countries, okay.
Yeah. So and the y-axis is the number of surfers I am trying to forecast.
Right. Right. So you have surfers coming from different countries plotted every year, and yeah, I guess some of it is actual and some of it is forecasted data. Is that what you kind of talked? 2005. Every year, right? Yeah. Okay. And what do you want to do with the zoom it? I think that may make sense even better. Pretty nice, pretty nice. So every year, different surfers are coming in. So different surfers are coming in from different countries, and you try to plot the actual data and then try to forecast some data, right? Or is that correct?
Yeah, so I built, I used a linear model to basically forecast this data. And yes, exactly like you said, I'm trying to just make this a little more clear.
And the idea is, sorry, go on, Alessandro.
Sure. So one thing that comes to mind is maybe grouping them. So rather than trying to, you said there are 19 countries here. Is that what we're looking at?
Yes.
So rather than trying to plot all 19 at once, maybe if we have something like by continent or by socioeconomic group or something like that, so to get it to a slightly more manageable number, so then we might have like 5 graphs of 5 countries or something like that, so we could actually see.
I see. Yeah, that makes sense. I was wondering, maybe there's a way, or if there's a way to like layer in like a horizontal line between each color break, like a black line or something like that. That way,
yeah. So what happens with stacking is, I guess, once you stack it, you can't compare individual elements that easily, right? Stacking is very good to compare part-to-whole ratios, right?
Right.
So if the idea for your communication, I'm guessing now you're communicating this data, or maybe at this moment, you're trying to say, how do I communicate? Is the part-to-whole ratio changing, right? If that was the objective, you could index everything at 100%, right? So you could index everything at 100% and then say, is it in Australia, the number of people changing, or whatever, USA, I guess that's the USA, right? And then you can see how the part-to-whole ratio has been changing, right? So that would be one message that you can get out of the chart, right? Saying, traditionally the USA has about 50% or maybe 40%. You'll have to index everything to 100% on the top, right?
Right.
And then you can see how that profile has changed. That's where stack comes in better. That's the same thing you do with pies, but pies are even worse because you can't show them. But a stacked graph like this would be great to do basically part-to-whole ratios, and where you want the messages more around have different countries declined or increased, and then you may have to also arrange those countries in an order in which the message comes clearly, because it's easier to compare when they are lined together on a horizontal base, right? If the idea was to actually look at overall trends across, then you should just plot each of these countries as a line, because it's basically a timeline, right? So you can just plot each one of them as a line, and then you will be able to see individual trends, saying in the US, is it going up and down? Is it going down? You would basically plot them as a line chart, right? A line chart for each of these countries would give you the trend and say, is the trend going up? Is the trend going down? Then you can compare like to like, right? Which is what I guess what you're trying to do when you're saying, I want to put a black line between those two, right? Now, the challenge with a line chart would be 19 lines are become pretty messy fairly quickly, right? So you may need to decide which are the ones that you want to. We can't focus more than 4 or 5 data points typically. So data lines, I would say 5 or 6 is probably the limit. ggplot, for example, if you start to plot shapes or colors, it restricts after 5 or 6 automatically. So because we don't have the visual perception to look beyond 5 or 6. So you may want to say, what's the message you're trying to find? I mean, is there something about US you're talking? Is it about some of the big countries you're talking? Aggregation could be one if that is what you're trying to do, which Alessandro is saying. So you could try lines, and you can then see how those intersection points work. I mean, that could be another way to think about it.
Yeah, I think maybe I was trying to communicate too many things with this chart. I think, indexing it at 100% is probably one chart, and then maybe using a line chart with a facet wrap by country to get like a quick snapshot of just general trends of countries over time might work.
Yeah, small multiples or facet wrap would be even great. I mean, if that's each country plotted, yeah. I mean, if that's kind of like 19 plots, yeah, you could do that. You could do that. That may work. Yeah, that would be the only way to kind of get 19 countries across. Or you could do even a complicated one where you plot the same continents and plot those 4 or 5 countries from those continents in a facet, right? So you may get less facets and you may get more of the data. So, North America, these 3 countries, Asia, these 3 countries, that could also probably work.
So a couple of things I want to add to that. One, actually, to answer the first question about the colors, you can play with the colors. There's a library called Color Brewer, which I think is automatically installed with ggplot. So you might poke around with that. Now, most of the color schemes in Color Brewer max out around 5 or 7 for exactly the same reason that you mentioned, that you can kind of only take in so many different things to begin with. And the other thing I wanted to kind of just reiterate is that the order in which you present the countries, you might want to pick an order that makes more sense for the data rather than just alphabetical order.
Right.
So what we're seeing is like USA is the second to the top,
right.
Because it's the second to the last in alphabetical order, and then you have it looks like ZRF or ZAF. I'm not sure if that's what that is, but that's sitting on top, and there's sort of this like little red line, which is hard to make out. So I think what a common strategy would be to rank it in ascending or descending order. So maybe put US at the bottom because it's the biggest part.
And so you would do that by refactoring the levels, basically, and then
Okay. Sorting it,
Gotcha. Okay.
I think what you're trying to do, the 2 things to think about when you're trying to communicate with charts. One is, what is the uniqueness about the data that you want people to come across, right? If you think from that lens, a lot of these questions get answered very easily, right? So instead of thinking about chart libraries, what you want to say is there something unique about the data that you want people to take out, right? And what a uniqueness, in most cases, it's a pattern, it's a trend, it's a deviation, it's an outlier, right? These 4 categories would probably cover 95% of anything that's unique, right? So, if it's a pattern, it's a cluster that you want people to focus on a gap you want, right? Or it's a trend. In this case, maybe it's a trend, right? Or it's some deviation. Like traditionally, there was lots of people that used to come from one country, and now that profile is changing. Maybe, maybe clearly the oranges have become a little big, so whatever was orange, Canada, maybe is going up, and or Australia and RSA. So it could be something unique about that data that you want people to come out. Now, if you start thinking about that part, you can explore in many ways, but when you start to communicate, the communication should really be about what's unique about the data that you want people to see. And once you think that way, then you can start to understand what chart or what representation would work better to communicate that. Right? So the visualization should bring out that uniqueness, that somebody can look at it and say, okay, I get it. That's what you're trying to tell, right? And and some tricks are there. So we can talk a little bit about, so when you're trying to do here, multivariable, right? Or at least in this case, time is one, and path to whole you're doing, right? So stacking typically helps. Time, when you're looking at timelines, typically lines are better. You can index it if that's the message that you want to say. Even in a line chart, you can index it, right? You can say, what's the growth if you want to show that. So there are some other techniques like that that you can actually try to see. But don't put more than 4 or 5 different colors for categories. We can't really take that much difference in.
Okay.
Could you reiterate those 4 goals in visualization, or 4 types of graph?
Oh, so I kind of talk about data abstraction. So I say, what are you abstracting from the data? And the abstractions are typically around whether there is a pattern. So the first one is pattern. So you're trying to look at patterns, especially when you're trying to do clusters or you're trying to do scatter plots. You're really looking for patterns. Where are things together? Where are things not together? Where there's a gap? Where there is where there are gaps and so on. So you're basically looking for a pattern in that. The second is trends. And this chart is very representative of a trend that you're really trying to see. Is there a trend that's going up? So where are you looking for? Is the sharp increase, sharp decrease, intersection points in the trend, and all those kind of topics. That's the second type. The third is really deviation. So it's like something that's happened out of the ordinary, deviated dramatically. And that may be the kind of third type you're trying to see. And the fourth is really outliers. And I think outliers tell a very interesting story mostly. And if you can find those outliers and talk about, okay, why is that outlier special, or why is that bunch of outliers special, and is there something interesting to talk about? I think that kind of covers 90% of what is interesting about the data abstraction that you have. And then depending on that abstraction, you may need to choose a visualization that brings that out. So I think you really want to choose a visualization that brings that uniqueness about the data very easily. Right?
Cool. I hadn't heard of that taxonomy before, so but I think it's interesting. And I guess what I'm getting from this is, so the patterns and trends I kind of see as kind of related. Patterns being patterns between groups or between instances, trends being over time, and then deviation and outlier seems like the biggest thing. The difference between that is deviation, we're talking about maybe a group that is very different from the rest, whereas outliers would be individual instances that are very different from the rest. Am I getting that right?
Yeah, I think that probably makes sense. Yeah, I mean, yeah, deviations would be more. Yeah, no, that makes sense. I mean, that makes sense. I mean, the traditional Anscombe thing, you can think there is one outlier chart there. There is one clear trend chart there. There is one clear deviation from the normal, and there is maybe another trend. There's no pattern too much, but there's another trend which is quadratic in nature. So yeah, I mean, Stephen Few has a very good book called Now You See It, which is around visual analysis and how do you start to visually look at these things and start to pick out visually from the visualization, what do you pick out? And Now You See It kind of teaches you how to start to look at graphs and pick these stuff up the same way, as I said, a radiologist would look at an X-ray and start to pick this thing up.
Right.
So I think that is key, and then I think the communication chart that you choose should really bring that out. Like, should really, kind of bring that aspect out, right? I mean, should really enhance that, so people can look at it and then kind of make sense of that.
So I think I guess those four kind of relate to when we're trying to communicate something that we found to somebody else. Now, but we also use visualization. Like, I think that Julian is probably more at the stage of doing more exploration.
Yeah, correct.
Say we don't even yet know what we're looking for. Do you have any tips to? I mean, besides what we've already said about maybe playing with the order grouping, trying not to present too much at once. Is there anything more you'd add to that might be particularly appropriate in the exploration phase?
Yes, I think in the exploration phase, when you're really looking at data, I mean, we kind of talked a little bit last week about single variable exploration, right? So if we look at kind of two variable explorations, double variables, one of the common sets is kind of like the one that Julian has sent, which is, actually it's 3 now, but you may want to look at if it's only categorical variables, so categorical, like, countries on one side and maybe another category, 2 categories, and then you're trying to plot them. Then typically, bar charts could work, stacked bar charts could work, or you may even want to, dodge them and start to see individual trends. So you're trying to create different charts out of that and see how each one of them has changed. One of the charts that I use a lot to kind of see these when there are 2 category data is, let me see if I can screen share. And is basically mosaic plots, and I don't know how at least they work very well for a lot of these communications, even for exploration. Let me see if this works. Is it clear? Is it coming across? No.
Yes, I see. Yeah.
Right.
So this is the cut versus clarity stack bar chart.
Yeah. So
And this is an example of putting the max at 100%, so you can see really the proportion of each in this case, the clarity of each cut, and how the I1, whatever that is, sort of shrinks to nothing as the cut gets better and so on.
Yeah, so I think let me just show, like, what Julian had done was this kind of, he'd done a stacked bar charts, right? And I mean, they were all stacked and it's hard to see. You could actually just dodge them in ggplot, and that itself would make sense, but maybe not for the number of categories that Julian had, right? Okay. But if you could actually stack them, then you can basically get to those same insight and start to see how some of them are changing. And then, as you mentioned, ordering makes a big difference, right? So how you order them would have a big impact in interpreting the results, right? Because you can probably...
They ordered it in this case is kind of interesting, because you see at the bottom the I1 kind of fades to nothing, and at the top the IF kind of come into
play. Yes. Yeah. And which makes sense, right? I mean, in this data set, ideal diamonds, which are cut nicely, are also diamonds which are good, which is internally flawless. Like, so the good diamonds are also good cut, but the ones that are fair diamonds are probably cheaper diamonds, and you don't probably focus too much on clarity. So cheaper diamonds are kind of fairly cut, right? So you can start to see that and start to make sense the data. So but that's a good way to think about it. Yeah, sorry, go on.
Yeah. And so this is particularly, I mean, having this order from clarity of I1 to IF makes sense, because those are actually graded. Like,
yeah,
S1 is better than S2, and S1 is better than BS2. As opposed to countries where whether you put the United States in front of or behind Canada is kind of arbitrary.
Correct.
There's not, it's not that there's a natural progression from one country to another.
Correct. Yeah. So you can yeah. I mean, you basically can see whether the data itself speaks for something. So ordering is inbuilt in, or then you do basically sorting. I think what you recommended was right on the mark. That you try and sort it in the terms of number of data availability, or whatever is bigger, ascending, descending, and that can also kind of help you think about it. And so then I think, sorry, this is just the third representation of the same data, or the fourth representation, which is mosaic. And I think this is not easy to do in ggplot. There's nothing inbuilt, but now you've actually used both the dimensions of area to actually show it. So you can actually see that even though we can, in the previous one, all of them are equal, right? You'll say fair is equal to good, very good. But now you're actually also distributing the length of the bar based on how many of that data is there. And you find that there's far more ideal diamonds than fair diamonds. So if you want to look at the data, then maybe this is another way to kind of look at it. I mean, this works great for understanding, but also for communication. I think I like them really well. So, some of the traditionalist visualization will say it's hard to interpret.
So it looks like GGMM plot was created by hand, or at least when I just read this now, and it looks like there's some code for it. But there's another library that might come in handy, which is called ggAlly.
Yeah, correct.
It has some extra things sort of tacked on to ggplot to do some kind of more fancy stuff.
Correct. Yeah. So ggAlly is pretty is kind of built on top of that, right? That's right. So this is like a function defined in it, which is also okay. I mean, you can define it once and keep reusing it for data. So I think when you're sorry, go on.
No, I was about to. Well, yeah, I want to change the topic slightly, but let's finish up with.
Yeah, so I think that's it, and when you start to see more, more kind of distribution in histograms and all. I think what I find is instead of using histograms and stacking them, what you can do is either facet it, which is what one of the ways to do it is. Or you can actually faceted with no, but kind of keep the scale same, or do frequency polygons, right? So frequency polygons is another way to kind of look at the distribution and compare across many categories, right? And yeah, that's a good way to kind of overcome this problem of how do I look at the same many histograms on one on top of the other. And you can do box plot facets also, but I think I find that is a good way to kind of look at the peaks and try and see. I think, yeah, so this presentation or some kind of approaches to this is, I think I posted it on the community, kind of flip through it, and we kind of stop here and then move to maybe some of the other questions we have.
So one of the things that we were going to talk about was all the different tools that people can use in data science. For this course, we're really focusing on R, but you mentioned that some people had asked about Python and D3. There's one that actually I think kind of comes in that I was just thinking about with regard to this data set and the problem of plotting multiple dimensions, especially when you're including time as a dimension. So, Amit, are you familiar with Hans Rosling and the Gapminder project? So
yeah, I think that's pretty good. Yeah.
So for those of you who don't know, I'll try to remember to post a link to his TED Talk, where he demonstrates kind of some interesting and very different ways of exploring data and presenting it with a time dimension. And the neat thing is, this method has actually been included into Google Charts. So, unfortunately, that means you have to use Google Charts, but it's all a lot easier than building it yourself. So, I think it can be difficult to describe, but basically, what he does with that is you have maybe 3 dimensions that you're trying to measure plus a 4th time dimension. So you might have, or actually really 5 dimensions.
Yeah.
You have one categorical variable. So usually for his charts he uses countries, but it could be any kind of categorical variable. And then you have 3 other scalar dimensions, which will be represented on the x and y axis, and then another one which is size. So you have these little bubbles. Each bubble is one of your say one of your countries or something like that, and it will start off at a coordinate, x and y coordinate, and a certain size, and then as time goes on, it'll move around. It'll change size and move around the chart. And it's a neat way to sort of see how different countries kind of move in this space and how different variables kind of interact with each other over time. So it's definitely, to my knowledge, there's not an easy way to do this in R, although I wouldn't be surprised if somebody's actually written a plugin by now. Since this has been around.
No, there is a plugin in R called Google Viz, which can actually Google Viz. So there is. I posted another presentation on the science on interactive charts, and basically what Hans Rosling has done is kind of like it's a little bit of interactive, right? So you want interaction, which means it's either mouse or in this case motion, right? Time, dimension, and motion. So somebody's built a plugin for that called Google Viz, and you can actually take Google Charts and it's called Library Google Viz, and you can just do a demo of the World Bank and basically see that same thing, and so that's great. And I think there is so I think on the tools dimension, I mean, one of the things you struggle with is interactivity, and how do I go beyond beyond static charts in R, and that's where D3 or D3.js kind of comes in, and or people even start to look at Python as a way of kind of building more interactivity into it. My thing is, I think before you kind of broaden this horizon and say I want to talk a lot about tools, and I want to kind of broaden my spectrum on tools, and I want to learn D3, I want to learn Python, I want to kind of build more and more on this. I would say even in R itself, there are some ways to get more interactive, right? So you could go and learn Google Viz, you can learn R charts, you can learn ggviz, which is kind of ggplot, next level on kind of interactive visualizations. You can learn Shiny, which is another way to kind of do interactive visualizations on R. And I think there is enough scope to kind of build on it. And at a later stage, when you feel the need to kind of broaden the horizon and say, now I really want to do a communication project and kind of really communicate this online, and I think something on a web-based, pure web-based, D3-based would make sense, then yeah, go down that path. But at the moment, pick a tool, and if you started with R, explore R, and you can do enough interactive stuff in R itself with Google Viz and all that, and then later on decide to kind of go beyond that.
Also, I'd like to make a little comment about D3 because I think D3 is very attractive. It's very good at making a lot of the great interactive visualizations that you see on New York Times, for example, are done with D3. But it is not easy to use. It in fact requires quite a bit of knowledge of JavaScript, the DOM, and you kind of need to know all three pretty well before you can really do anything with it. So it's really meant for people who are already very accomplished front-end web developers, frankly. Now, the neat thing about D3 is that it's designed to be a framework. And so people are starting to build tools that sit on top of D3 to generate D3. And as that kind of evolves, I think that that's something that we as data scientists who maybe don't have so much of the background in JavaScript and the DOM and SVG can use those tools to generate stuff in D3. But I think that it's D3 might seem like, oh, this is what everybody's using. The fact is that actually not that many people are using it because it does require so much expertise just to get off the ground with.
Yeah, and I think some of the tools
so yeah, that's.
Sorry, go on.
Oh no, that was my thing about D3.
Yeah, no, I think some of the tools that people are now building, like R charts and ggviz, are built on top of D3, which means you can access them from R, but you don't need to learn D3, at least at this stage. So you can at least get output that's onto the web and interactive, or at least not on the web, but you can play with it within RStudio and interactively, and then yeah, go down that level when you're ready to.
D3 is like the machine language of visualization. You can drop to that level if you need to, but hopefully you don't have to.
Yeah, I think it's good to use 1 or 2 levels of it. Yeah. Okay, so I think we can go on a lot on visualization, but maybe we'll kind of cover the other couple of more topics on scraping and clustering today, and then maybe we'll come back to visualization next week and talk a little more about interactive or multivariable visualizations next week and kind of go down that. So I think one of the questions that that came in, and I think also inspired by something you put in, scraping, right? So getting data inside getting the data, number one, right? And some of us are lucky, like you are, working with companies where there is log data flowing in, every second, every millisecond, and you probably have enough stuff to do with that itself. But some of the other people may actually have to get the data the hard way, and how do you? So one of the, I think before the call we were talking about kind of how to get data in, and I kind of the hierarchy of getting data in is, when data is already there from some internal system, it's available to you, would probably be the easiest. Second, maybe an API on the web or some API that you can hit and get the data in, or some public data, as in data.gov or data.gov.in, all these World Banks and all those sites who may have data available to go. And those are the kind of easy stuff to get. And then you go down the the more harder stuff, which is data that you have to scrape from a website, data that's embedded in a PDF, and then you need to kind of take it out. And in some cases, data that you literally collect yourself and make it up, right? As in in the sense of getting the data from different sources, triangulating it. And maybe that works for smaller data, maybe not big data, but at least big data, right? So acquiring data in, so I think on the lower end of the spectrum where you're not getting, how would you approach this? So let's say if you are on the top end where you have an API or something, is R something that you can use to directly hit the API and get the data in, or is that you basically get the data from somewhere else, put it in a database and then take a CSV or some dump and then put it into R? How do you approach it on the top end of the spectrum?
So let's see. So the best data source is a database because it's everything is pretty much, you have a lot of control over it. It's pretty much what you want. And there's database connectors for everything in R. I think last I tried connecting to Mongo with R, it was not so good, but I think that's probably come a ways since the last time I tried that. At least I hope it has. Then there's, as you said, APIs. APIs are almost like public databases.
Right.
They're designed for computers to use. One that I've been mentioning recently to some of my students is Freebase, which is basically like Wikipedia for computers. Wikipedia itself actually has been really trying to make its data more computer friendly. But Freebase is designed from the ground up to be something that a computer would query to get information. Freebase actually gets a lot of information from Wikipedia, so but it's designed to have an API that you can kind of programmatically interact with. But then, so say you don't have that. Maybe the next one would be, actually, before the call you mentioned that you've had good luck just asking people for data. And I think that's a good point to make. I think that we often, I don't know about you, but I've gotten to the point where I expect to be able to do everything on my computer, and if I have to actually ask somebody, I kind of bristle. But
don't deal with humans, Just
The second a human becomes involved, I feel like I've done something wrong. But as a matter of fact, I'm often reminded that that really is often the best way to go, and can be the path of least resistance. Just a lot of people. I mean, it depends a lot on the data you're interested in. I mean, if it's corporate secrets, you're gonna have trouble. But a lot of people are just gonna be so thrilled that somebody finds their work interesting enough to do something that you might make a friend for life just by asking them to see their data. And now that data might come across in a way that might not be the best for you because what they were trying to do might be a little bit funky. So, or for example, I've had to for a project I was working on, I got cost of living indices, which were in these kind of weird Excel files. Not really weird. I mean, they were normal Excel files, but they're weird from a computer point of view because the authors, they weren't really concerned about a computer reading it. They were expecting humans to read it. So it would have things like 3 rows devoted to a header, and the header would be broken up, basically like word wrapped, but in 3 separate rows, which to the eye is fine, but to a computer is like, what's going on here? Why is the title on the 3rd row, and why are 2 of them the same? Because of course the rows above it, it's different, but just on the 3rd row, it's the same. So you kind of have to like play with it and go in there
How do you clean it up in that case? Is like, do you use some tools for that, or are there any guidances?
So I I prefer to I try to avoid anything that I can't programmatically do if I can at all avoid it. So what I will do in that case is I will write a script that will read directly from the Excel spreadsheet exactly as I received it, and then make the corrections after I've done the import. And so the corrections will be done programmatically. So I can, for example, and this is the reason why I do this is because, say I get the cost of living index for 2013. Now a year goes by, I want to add, I want to update the data with 2014. Well, hopefully they haven't changed their format. In fact, they probably have. But assuming that they haven't, then I could just feed in the new file and rerun everything and not have to, and do it all in a few minutes.
Makes sense.
Whereas if I had to do the pre-processing, if I did the pre-processing in Excel, then I would have to go, a year later, I would have to dig through the cobwebs and try to remember what it was that I did last year.
To make it right,
Yeah, and so, did I normalize it? Did I scale it? Yeah, I don't remember. Did I scale it on 0? So yeah, I try to do as much of that in code as I possibly can. And then,
one other tool that I've used, or at least experimented, is something called Open Refine, or Google Refine it used to be, where you can do some amount of kind of programmatic refinements and cleaning up of data, but also in a kind of GUI-based, or I guess best to express, kind of GUI-based. So people who are kind of a little more hesitant to go full down in a programmatic cleaning can try that. It is also repeatable, I guess, to some extent, and you can apply it to the same databases again, and it can handle more data than an Excel probably can, or maybe more than Excel for sure.
I've never used Google Refine myself, but my colleagues at Glassdoor, a couple of them swear by it. So I would definitely, relay their endorsement.
So what about the third type of data so you ask for it and you have or you have an API and all, but sometimes you have to scrape, and sometimes you have to scrape the barrel and build it yourself. And what do you do in those cases? How do you go about that?
So then you have to use, it's can often be helpful. You don't have to do this, but it's often helpful to use tools that are built specifically for this process. In Python, there's something called Scrappy or Scrapey. And I recently learned that there's some stuff for R that kind of works the same way. So I think RBest seems to be the tool that I've seen for others. And the way these work is they kind of depend upon the web page having a certain, or the web pages, because you're usually doing this with a bunch of web pages. You're doing it just with probably copy and paste it into a spreadsheet or something like that. But if you're trying to scrape either a whole website or just a whole something like that where you have a lot of pages that you're trying to ingest, you're kind of depending upon the fact that the data is going to be presented in a formulaic way, that there's a pattern to the way in which the tables are formatted. And this is going to be generally true because all of these web pages are themselves programmatically generated.
Correct.
They're basically drawing upon some database and then using some query or whatever, generating this the data that it's showing you on the web. So so you're basically just matching that pattern, and you're doing and then you program it. You're doing pattern. The program is doing pattern matching on the website to basically pull out the data that's actually that's what you're trying to get. The problem with this is that it's very fragile. First of all, you're reverse engineering how they created the web page in the first place. So you might get it wrong. It might look exactly right for the page that you're modeling your pattern on, but it turns out that there's some other contingency that you didn't account for, and the thing breaks. Another thing is it also the second an update comes out and they change something, your
It breaks your script, yeah. It breaks everything.
And then of course it's good to be aware that there are some companies that will actively try to prevent you from scraping the website. So, for example, LinkedIn will they have some really interesting stuff where they actually bounce the client back and forth between a couple servers before they actually show you any data. You have no idea that this is happening when you're doing it when you're browsing on your web client, but when you're using something like Scrapy or RVest or whatever, or RPipe, it's going to get lost. And then they also a lot of companies will have if you issue too many queries within a given time frame, it'll cut you off. So you can only look at so many websites at a time as a human, but when you've got a computer loading pages, that increases by several orders of magnitude. So it's fairly easy for a web server to tell the difference between a human and a bot.
Right.
So they'll often try to cut off bots because that's their IP, and they don't want to lose that. So.
Yeah. So I guess be mindful of whatever the kind of the restrictions are, and in some cases they may be explicit, like the license, the copyrights, and Creative Commons, and you know what you can do and not do with the data. In some cases they may be more implicit in the sense of we actively find out if you're a bot and then kind of cut you off. And just be mindful when you're scraping data of the kind of legal implications of all that, right? So. But I guess there's a lot of Creative Commons stuff available now. I mean, where you are free to use the data, download it, or at least in a lot of cases, at least use it non-commercially, if not commercially, right? So, for your data projects or doing something funky to show off on your portfolio, it may not be too bad, as long as you're not making money off that. Right, so I think scraping is hard, scraping is fragile, and scraping can be difficult, but you may have to do it, and I guess all of us end up doing it once or many times. So and I guess the hard part, so I think that kind of covers the data kind of acquisition pipeline, right? And maybe for kind of next week, when we come back, we can talk both on the visualization side a little bit more about multivariables and interactive, and on the scraping side, now that you've got something in, are there any tricks in dplyr or whatever our library you use for scraping up, kind of data manipulation, or as we would call it, data wrangling, or really, wrangling with the data, what we can do different with those parts. So I think that would be nice. We cover a little bit of visualization and then start to get into module 4, which is really around trying to get better at data wrangling. And that data wrangling is inevitably the biggest part of a data scientist's life, right?
Yeah.
Acquiring and wrangling, I guess. Acquiring and wrangling is probably 80% of the work, or at least in some cases. So I think we're just about at time. Any Christmas messages you would like to give off, Alessandro, before we sign off?
Got me flat-footed.
What does one data scientist tell another data scientist on Christmas?
I give up.
Log. I don't know. I had this. I think I was reading the maths guys all say log. I don't know what a data scientist. We need to figure one out.
Yeah.
So. Yeah.
It's just a good one.
Well, I guess everyone have fun. Have a good Christmas, and I think we'll see you on the other side of Christmas. And maybe I don't know what the date is, but everybody will know the dates. I think Monique will put them up when the next one is for the next office hour, and we'll see you next week sometime.
That's right.
Happy holidays. Happy holidays, Alessandro. Happy holidays, everyone.
Thank you.